Hello dear students, this is Dr. Hadi here. Welcome to Medical Globe. Today's topic is from the biochemistry, that is phospholipids. As we have already discussed the lipids, the types of lipids, classification of lipids, today we will discuss phospholipid, because phospholipid is a type of compound lipid. And what are compound lipids? Those lipids, compound lipid, those lipids which contain, number one, glycerol as an alcohol, number two, fatty acid. These two are present from the beginning. Beside these two groups, beside these two compounds, there are additional groups like phosphate. When phosphate is added, now that lipid become phospholipid. But beside phosphate, you will find some more other extra group as well, like nitrogenous base. Nitrogenous base. Nitrogenous base is a compound definitely that contains nitrogen atom, and that compound has the ability to give its electron pair to other compound, because it will act as a base. Base give its electron pair. So I will tell you some of the structure of the nitrogenous bases in phospholipids. So these four groups are necessary for the phospholipids. Whenever you take a phospholipid, majority, not all, majority of the phospholipid, they contain alcohol. They contain alcohol, fatty acid. In addition to these two, there is phosphate and a nitrogenous base. So now phospholipid is not a single compound, because most of students think that phospholipid is the name of a single compound or a molecule. Phospholipid is the name, is a family name that umbrellas many compounds. Different compounds come under the shade of this word phospholipids. So phospholipid is no more a single compound. There are many compounds that everyone will generally be called as phospholipid. So what we did, we classify the phospholipids into broad categories on the basis of the alcohol. As I told you that in the phospholipid, alcohol is present. On the basis of alcohol, the phospholipids are of two types. If the alcohol is glycerol, it will be called as glycerophospholipid. Glycero, phospho is fine, but there is glycero because of the glycerol. And if the alcohol in lipid is sphingosine, that is some special alcohol, sphingosine, you will be provided the structure of sphingosine later on. But if the alcohol is sphingosine, that phospholipid will be called as sphingophospholipid. So we got two types of phospholipids, glycero and sphingophospholipid. Now we will come to the next topic, that is what are the compounds that are present under the heading of the glycerophospholipids. So there are some compounds, their names are mentioned here: Phosphotidyl choline, Phosphotidyl ehtanolamine, Phosphotidyl inositol, Phosphotidyl serine, Plasmalogen, Cardiolipin. These are the name of the phospholipids that will come under the umbrella of this glycerophospholipids. Okay, and we will share the structure on the whiteboard. And some students, they feel it very confusing. They say, they're complaining that we can't memorize the structure of phospholipid. So don't worry, today you will be given a very vivid, clear idea how to memorize the structure, and you will memorize it definitely. But you need to watch this video till the end. If you want to memorize the structure of all these phospholipids, you need to know the structure of the phosphatidic acid. And if you want to get the structure of phosphatidic acid, I want you people to move back towards my previous lecture where I have recorded the topic on acyl glycerol or triacyl glycerol. That you must go there, and if you know already, that's fine. Okay, so first our target is to know phosphatidic acid, and if you want to know phosphatidic acid, you need triacyl glycerol. You need what? Triacyl glycerol or triglycerides. So what is the structure of the triacyl glycerol? In triacyl glycerol we have 1, 2, 3 carbon, and with every carbon OH, here H2, here single H, and here we have H2. This is glycerol. Oh, we got it. Glycerol. With this one glycerol, 3 fatty acids are attached. 3 fatty acid. One fatty acid will attach here. That is C double bond O R. R C double bond O. The red color shows a fatty acid, and we already know how these two combine in my previous video. You can see. So today I will not explain it again. So here again another fatty acid R C double bond O, and one more fatty acid R C double bond O. When 3 fatty acids attach with one glycerol, then it becomes an ester, and that name of that ester is triacyl glycerol. Fine, this is the structure of triacyl glycerol, which was already discussed and once again revised just for the sake of the convenience. It was revised. So this is triacyl glycerol. If you want to get the structure of phosphatidic acid, what you need to do, you should remove only one fatty acid, and in place of this fatty acid you should add one phosphate group here, like this, PO3 or PO4. This is very simple form, right? Now it becomes phosphatidic acid. But you people are student of the advanced level, you are student of the master level, so you need to write it like this: O P double bond O, single bond O, single bond O. Here negative charge, negative charge. This oxygen has no charge because it is already bounded with it has already made 2 bonds, and this oxygen has also 2 bonds. So the oxygen with 2 bonds have no charge. These 2 oxygen have lost their hydrogen. Actually the phosphate comes from the phosphoric acid H3PO4, H3PO4 phosphoric acid, and the structure is very special. That is, there is 1 phosphate and 3 hydrogen, 1 double bond oxygen, and here OH, and OH. Now this is fine. 4 oxygen and 3 hydrogen, 1 phosphate. This is the original structure of phosphoric acid. So if you remove this hydrogen, it will become O negative and it will become O negative. That's why we write the structure like this. It is actually a fatty acid. It is actually a phosphate that is made a bond with the CH2OH group, and it is again of course an ester bond. Now this become a phosphatidic acid. So congratulations, you got the structure of phosphatidic acid. Now once you got the structure of phosphatidic acid, now we will come to the structure of phosphatidyl choline, which is also called as lecithin. If you want to write the structure of lecithin, what you need to do, you should write a nitrogenous, you should add 1 nitrogenous base here, 1 nitrogenous base. Nitrogenous base is because here the word is choline, so you will add the word choline. If you add the word choline, this will be not enough. You should write the structure. So the structure of choline is CH2 single bond and one nitrogen. Around this nitrogen we have how many CH3 methyl groups? We have 3 CH3, 3 methyl groups, and one plus charge here on the nitrogen, because nitrogen usually make 3 bonds. Now nitrogen has made 4 bonds, that's why. So the black color that you see is a nitrogenous base, and that nitrogenous base, once add with phosphatidic acid, the whole molecule will get another name, which is called as phosphatidyl choline. So what we will write? We will write phosphatidyl choline. So once again, congratulations, we got the structure of phosphatidyl choline. So where are those students who would say that the structure is too complicated? It is not complicated, very simple. So we are following only one structure. Now this becomes phosphatidyl choline. Now if you add another nitrogenous base, that is here, that is ethanolamine. The structure is like this. You will add CH2, another CH2, and here you will add NH2. Now this is ethanolamine. It was in the beginning, when it was free, it contained one OH group, and now the OH is not mentioned because the OH has already made a bond with phosphate. So the OH is not mentioned, only CH2, NH2 is mentioned. So this is what? Ethanolamine. All OH is not mentioned because OH is already used, although it contains OH because it is ethanol. So the OH. Now this name of this one is phosphatidyl ethanolamine. Phosphatidyl ethanolamine, and its another name is cephalin. Okay, fine. Now if you add inositol is like this. That is inositol, right? You can add C, 6 carbon are there. It looks like a sugar. So when you add inositol here in place of nitrogenous base, it will become phosphatidyl inositol. And if you add serine is the name of an amino acid. If you take serine here in place of, it will become phosphatidyl serine. So we got the structure of these 4. Now I will come to the structure of plasmalogen. What is plasmalogen? Again, come to the phosphatidyl ethanolamine, same structure. In plasmalogen, here we have at carbon number 1 we have a fatty acid. If you add another group here, what kind of group that is? If you add an unsaturated fatty acid like CH2 double bond CH and then R CH double bond CH, this is a fatty acid. But what kind of fatty acid it is? It is an unsaturated fatty acid, and the bond here, this bond is not an ester because these are ester bonds, and that was ester bond. Now it become ether bond. So 2 changes. If you bring 2 changes, if you made 2 changes in the phosphatidyl ethanolamine, 2 changes. The first one, there is an unsaturated fatty acid at carbon number 1. Number 2, the bond become ether in place of ester bond. Then it become, because we know ether, that is ROR stands for ether. If this formula comes, it is ether. And RC double bond OR, RC double bond OR, this is for ester. This is, look, RC double bond OR. So this is ester bond, but this is ROR. So the bond become ether. So a slight change we made in the phosphatidyl ethanolamine. Now it become plasmalogens. It now become plasmalogen, and it is also called as phosphotidal ethanolamine. Phosphotidal, not phosphotidyle, just dull. Phosphotidal ethanolamine. Okay, fine. So now the last one is cardiolipin. How to write the structure of the cardiolipin? Now the scenario is a little bit changed. So cardiolipin, for cardiolipin you need 2 glycerol, you need 2 phosphoric acid, phosphotidic acid, this is first one, another phosphoric acid, PHOS, phosphotidic acid. I can't write the structure again because I have already mentioned 2 phosphoric acid molecule. You will write, fine, and in between these 2 phosphoric acid you will add 1 glycerol, and you know very well, more than me, that glycerol contain OH groups. Yes, it contain OH group. If that glycerol make a bond with this phosphoric acid and that one, by the help of what? By the help of phosphate, because phosphoric acid contain which group? Phosphate group. Yes, this phosphoric acid also contain which group? Phosphate group. So if this phosphate make a bond with OH like this, I'm removing this H, O, now you need to write it as a PO3. Now O, PO3, O glycerol and PO3, O glycerol. Fine. Now this become the structure of the phosphatidic acid. You can write, you just take out your page, pencil or pen, draw the structure, you will get it. So 2 phosphoric acid molecule, in between these 2 you got 1 glycerol with glycerol's OH. You combine, link the glycerol on its right and left side by the help of phosphate. Now this is this is cardiolipin. Why it is called cardiolipin? Because it was first found in the tissue of the heart, and that is why. And it is the only phospholipid that shows the antigenic activity. It contains antigen activity. Not all other phospholipids contain antigen activity. This is the only phospholipid that possesses antigenic activity. This is so special to say. And it is also present in the membrane of the mitochondria. The decreased level of this phospholipid will lead to numerous types of diseases. So now we will come to the next category, that is sphingophospholipid. The structure of sphingophospholipid is very complicated if you see it directly, and slowly after some time you will say, okay, you will give a smile, okay fine, this is so easy. How? Come to me. First, if you want to get the structure of sphingophospholipid, you will focus first on that simple diagram. In sphingophospholipid, we have a very good example of one, that is sphingomyelin. In sphingomyelin we have 3 groups, that is sphingosine attached with a fatty acid and a phosphocholine. These 3 groups are present and they will make a sphingomyelin. So let me write the structure for you people. First of all, we will write the structure of a sphingosine, because sphingosine is an unsaturated amino alcohol. It is what? It is an unsaturated amino alcohol. Unsaturated means there will be a double bond. Amino means there will be amino group. Alcohol means there will be OH group. So this is sphingosine. Let me write the structure of sphingosine. If you want to write the structure of sphingosine, you need to write 18 carbon. So this is the first one as CH3, remaining 12 carbon like this, CH2, have 2 brackets right here, 12, means 12 CH2, 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 many CH2s. I just mentioned in shortcut form CH2, bracket closed, 12 here at the base. So 12 carbon and 13 carbon, got 13 carbon gone. 14, 15, 16, 17, 18. Remaining 5 carbons are very special. Up to this place, so easy. You can write very easily by just closing your eyes. Fine. Now remaining 5 carbons are very important. Then you have carbon number 12. This is 13. Okay, 12, 13. Now you got 14. Carbon number 14 and carbon number 15. In between the 14 and 15, you will add a double bond. 14 and 15. Sorry, this is carbon number 14 and this is carbon number 15. Between 14 and 15, you got a double bond. Then another carbon, you will add an OH group. Here, you will add an OH group. This is at carbon number 16. And then another carbon, which we call it carbon number 17. At carbon number 17, you will add amino group NH2. Here, if you add an amino group, so this is done, and the last carbon is the 18th carbon is CH2OH. Yes, it contain what? It contain OH group. So 14, 15 double bond, 16 OH, 17 amino group, and 18 contain OH group. This is what we call it, special called sphingosine. Fine. So once you got the structure of sphingosine, now you will add another group, fatty acid. You will add a fatty acid here, but the fatty acid will make a bond with NH2 here. So in place of NH2, you will write only one NH, that is NH. Fine, this is now NH. And here we will add a fatty acid. So what I'm going to do, I'm going to write R C double bond O, and like this. Now this is for fatty acid. R C double bond O. The OH of the fatty acid is already used while making the bond with the NH2, because they will make an H2O and that H2O will be released. The OH, R C double bond O OH. Yes, of course, this is fatty acid. The OH of the fatty acid will make a bond with the hydrogen of the amino group, and that OH and H will combine in the form of water to leave the structure. That's why I have not mentioned. So R C double bond O. Once you add sphingosine with a fatty acid, now the structure becomes ceramide. That we call ceramide. CER, that is CERAMIDE, ceramide. One more thing also, when you say something, when you say this word with two students during Viva, say what is ceramide? You say, oh, ceramide is so difficult. Oh my God, so sorry, I just forgot. We have experience in it, but this is a ceramide. A sphingosine attached with one fatty acid is a ceramide. And now the last thing, it is still we have one more OH group. If you attach phosphocholine means if you make another phosphate group here, add another phosphate group here, that is O, P, double bond O, O minus and O minus, made you just add one more phosphate, and with this phosphate, if we add choline, and I'm very happy that you know very well about choline. Choline is CH2. What is about after that? Again CH2, and then tell me, that is nitrogen. Okay, fine. 3 CH3 groups are there with one over. Now this whole structure is phosphocholine. This whole structure is phosphocholine. So once you add phosphocholine, now it will not be called ceramide, it will now be called as sphingomyelins. Now this is structure of sphingomyelins, you got that? Sphingomyelin is the main component of the nervous tissue. It is found in your brain, and sphingomyelin is also involved in cell-to-cell signaling as a secondary messenger in apoptosis. Apoptosis. What is apoptosis? When a cell is when cell death occur, programmed cell death. One is the accidental injury. During injury, when death occurs to your cell, this is called as a necrosis. But as comparison to the necrosis, we have another apoptosis. Apoptosis, cell dies with program, with pre-plan. That's the time of cell is finished. So the cell starts some changes in it and cell become die. This is called as apoptosis. During apoptosis, cell needs some sort of signal. So that signal come from the secondary messenger. And that secondary messenger is your sphingomyelins. So overall, if you come to the structure, the heading of phospholipids are present in the biological membrane, especially the cell membrane, the mitochondrial membrane. What is the function of phospholipid? The function of the phospholipid is to regulate transport, to regulate membrane permeability. The cell membrane permeability is because of the phospholipid. So this is so important. And the second one is phospholipid act as a secondary messenger, as a signaling molecules. In the biochemistry, you will find these things. So overall, as a summary of my whole lecture, today we just discussed phospholipids. We discussed two types of phospholipid, and then we discussed the structure of different phospholipids, especially glycerophospholipids, and then we came to the last one, that is sphingomyelins, along with the structure. Dear students, if you got that my lecture, give us a like and also share it. Also subscribe so that you will be notified for the incoming videos. Remember me in your prayers. Thank you very much. Take care. Bye bye.